class. Today we are going to talk about section 4.4, which is the chain rule. We will be applying the chain rule to all the different derivative functions, all the functions we've learned how to take the derivative of, but now we will have to apply the chain rule to them. So, the first thing I'd like to start with is if you have a function that is a quantity raised to a power. So, you have a big, large quantity, and in this case, it's raised to the 5th power. So, you will use a version of the power rule, but apply the chain rule to it. So, let me demonstrate. We bring down the exponent, we rewrite what's in parentheses, we subtract 1 from the exponent, now we multiply it by the derivative of what's in parentheses. And that is the chain rule. So if we're just looking at this written as a rule, you have a constant, a u, raised to an exponent of n. U is a quantity that has a derivative other than 1. I should say other than 0 or 1. It has a derivative. Okay? So, if it is a quantity raised to an exponent, then that means the derivative is the coefficient times the exponent. You rewrite your u, you subtract 1 from the exponent, times the derivative of what is in the parentheses. So let's look at another example. Square root of x cubed plus x. So written as a quantity raised to a power, it looks like this. The derivative, bring down the exponent, rewrite what's in parentheses, subtract 1 from the exponent, and multiply it by the derivative of what's in the parentheses. If we're going to simplify that answer, it's 3x squared plus 1 over 2 times x cubed plus x to the 1/2, or we could write that as a square root. Okay, so that's our first version of the chain rule. The other functions that you've learned how to take the derivative of include your trig functions. So now we're going to have to look at it if they're a trig function to something other than just plain old x. So what if you have to take the derivative of sine u, where it's not just sine x, it's sine of 4x or something like that? Well, you just multiply it by u prime. So it's still cosine u, but then you multiply it by u prime. And the rest of the trig functions will work just the same. So this one will be negative u prime sine u. The derivative of tangent u will be secant squared u times u prime. Let me write that a little bit better. The derivative of secant u is u prime secant u tangent u. The derivative of cotangent u is negative u prime cosecant squared u. The derivative of cosecant u is negative u prime cosecant u cotangent u. Okay, so all of these are going to work the same. Let's look at a couple of examples. So if our function is sine of 4x cubed minus 2x plus 1, then the derivative is u prime, so the derivative of this is our u, so 12x squared minus 2, might want to keep that in parentheses, and then cosine of 4x cubed minus 2x plus 1. And it works the same for all of your trig functions. So if it's tangent of 3x, then the derivative will be 3 secant squared 3x. U prime secant squared u. Follow the formula. Your u will always be whatever the trig function is to. Okay, then the last two functions that you have learned how to take the derivative of are e to the x and a to the x. So we need to learn how to take the derivative if it's something other than just plain old x. So if we will remember, the derivative of e to the x is just e to the x. So now what if it's not just an x? It is a u, something that has a derivative. Then we're just going to have to multiply it by u prime. Do you see a common theme here? If your function is something other than just x, you multiply it by the derivative of that term. So, for example, in this case, if my function is y equals e to the 3x, the derivative will be 3e to the 3x. You might have to use the product rule. Let's say I have x cubed times e to the 6x. My derivative, I have to use the product rule. So it's the first times the derivative of e to the 6x. Well, that's 6e to the 6x. Plus the second term times the derivative of x cubed, which is 3x squared. Okay? You really have to think about what you're taking the derivative of. The other function that we've talked about is the derivative of a to the x. The derivative of a to the x was natural log of a times a to the x. Well, if it's not just a plain old x, it's a to the u. We're going to have to add on to that derivative. So we're going to multiply everything by u prime. U prime times the natural log of a times a to the u. So, for example, y equals 4 to the x squared. The derivative of that is 2x times the natural log of 4 times 4 to the x squared. Again, you might have to do the product rule or the quotient rule. If our function is y equals 3 to the 2x minus 1 all over square root of x squared plus 2. I look at that. I determine that I'm going to have to use the quotient rule. So I do the bottom times the derivative of the numerator. Well, the derivative of a to the u is u prime natural log of a times the problem, which is 3 raised to the 2x minus 1 in this case. So that's the bottom times the derivative of the top minus the numerator times the derivative of the denominator. How do I take the derivative of a quantity raised to a power? I can write this as x squared plus 2 to the 1/2 power. I use the chain rule. I bring down the half, I rewrite what's in parentheses, I subtract 1 from my exponent, times the derivative of what's in parentheses. Sorry, I ran out of room. So that's times 2x. All over the denominator squared. So that will cancel out the radical. Okay, let's do 2 more examples. So if our function is secant 3x times 8 to the 4x. I have 2 functions here. I need to use the product rule. The first times the derivative of 8 to the 4x. 4 times the natural log of 8 times 8 to the 4x plus your b, which is 8 to the 4x, times the derivative of the first, 3 times secant 3x, tangent 3x. You have to memorize your formulas. Make a list, study them, know them. If you do not memorize the derivative formulas for the type of function you're going to take the derivative of, doing the chain rule is going to be extremely difficult. So know your functions. I will see you in class tomorrow.